Everything's going to be recorded.
All right, who's going to do the operation of it though? Say I need a hotline work permit. Am I going to have to drive to the substation, turn off the reclosing relay?
No, you just call the operator or whoever, and have them do it through remote.
Right. Okay, you're just going to call your dispatcher, and he's going to do it by SCADA. Remember SCADA? And SCADA is going to do most of the monitoring right here. SCADA can do everything but one thing in this breaker. Okay, it can monitor the relays. It can open and close the breaker. It can get the reclosing relay turned off and on. Put our R down here. The only thing it cannot do is move the switch for local and remote. Now, in normal operation all day long, what position is it going to be in? Remote. Okay. I want somebody to remotely operate this breaker and have control of it. If I need to come to the breaker and do something inside, I don't have SCADA operation, or they're too busy doing something else for a long duration of time, I need to turn it to local. There's only one thing in remote, and this is a safety feature, only breaker open works. That's a safety feature. Okay. In remote, I can walk in, I can turn the middle handle to green, the breaker will open. That's all it will do in remote. Otherwise, anything I have to do in this thing, I have to turn it to local. Now, do you need to contact the dispatchers to let them know that you're doing that? Absolutely. Okay. As soon as you go to local, they'll still be able to see what's happening. They won't be able to control anything that's happening. So you need to let them know that you've got it in local. Local and remote. And the only thing that works in remote, as far as handles and all that stuff, is an open. Turning the middle handle to green to get it open. Okay. Now, the tagging relay, there's a specific purpose for it down here. If I want to get a hotline work permit and I don't have SCADA, the tagging relay turns off the reclosure. So what are the steps here? I need to go to remote, local. Of course, you're getting permission to do this. You're talking to a guy by radio, and then I'm turning off reclosing. You now have a hotline work permit, right? The orange, normal state, there is no orange flag. In non-reclosing, that means the reclosure is turned off, you will get an orange flag. That's an OSHA requirement right there. That you have visual confirmation that you have non-reclosing. Is everybody tracking?
Yes, sir.
Okay, good deal. All right. You can sometimes, if they're doing it by SCADA, this handle moves by a motor. So even if SCADA does this, you should have an orange flag in here. In the wintertime, when it gets severely cold, that motor's not strong enough to turn it. They might send you to the substation and say, hey, we're not getting a non-reclosing indication. Can you check the flag? And it might only be halfway. What do you need to do?
What, reset it?
No, it's halfway. I need to go all the way.
Okay, so you need to close it all the way.
Okay, what do I need to do first?
I think you need to lift off the permit. Wait, what's the in remote only breaker open? Oh, you need to put it on remote first. But then even before you do that, you need to lift the
in remote, only the breaker opens. I need to put it in local.
Yeah.
right? Then turn the handle all the way over. Remember,
Manual.
and that's
And then
a
put
lot
it-
of people. A lot of people walk up and forget that. Oh yeah, man, I'll take care of it. They turn the handle, but they weren't in local. It's not going to work correctly.
Okay.
Okay. In remote, only this breaker open close. That's for safety purposes. Works. Okay.
Okay.
All right. So really, I mean, if you want to be a relay technician or a substation maintenance guy, you can dig deeper into this. This is what a lineman needs to know. When they walk up to this, they need to know these components inside a breaker. Now, brand new employees may not happen, right? But you might walk up with somebody that's working there for a long time and say, hey, we've got non-reclosing. And that guy, I've done it. I worked there for many years. Oh, okay, well, I'll just turn this and make it all orange. What are you going to tell them?
That's
Hey,
wrong.
dude.
You got to put it in local first.
Hey, dude, you forgot to put it in local. Okay. So I put it in local. What I'll do is I'll put it in local, turn it all the way off, and turn it all the way back on, just to make sure. Now the dispatchers will get indication that it's working correctly. So you'll get confirmation. And you should have a full orange flag over here. Okay.
All right.
All right. Sounds good. All right. What time are we holding?
9:34.
Okay. Another thing you need to look out for here is when you go to local and you do your work, what do you do when you leave?
Switch it back.
Switch it back to remote. Yeah. Go ahead and switch it back to remote. SCADA might not be working or they still might be busy over there. But if they get SCADA back up and working, you're all good to go. Now here's one more safety feature here, and we'll take a break. If you're in local and you're opening and closing the breaker, doing everything that you need to do, right? And you open the breaker back up. So I'm going to change this to green. Okay, just for some odd reason you have to do to work. And then you leave, even if you put it back in remote, SCADA cannot close the breaker. Because the last thing it recognized here was somebody put me in open, right? That's a safety feature right there. Whoever did it is going to get a call back from the dispatcher. SCADA's back up, man, but you put that breaker in open. I need you to go back and put it to the closed position or red before I can close it by SCADA. That's another safety feature there. So SCADA really can't take over what you have done.
Got it. Okay.
Okay. All right. All right, good.
But you're not, I mean, you're not really, I'm saying you're not really closed until that recloser closes, though. Correct?
That's got nothing. Opening and closing the breaker by handle does not have anything to do with reclosing.
Got it. Oh my, okay.
Okay.
All right, because the reason why I asked is because I thought red means you're hot, you know?
Red is hot.
Yeah, but if you go hot, is that really hot? And is that really, is the circuit really hot until
Really hot.
until the, yeah, but the recloser hasn't reclosed yet.
When did we say it opened? We didn't.
Okay, I thought you did. I thought you said it open. You know.
Nope.
Okay.
Okay. All right. Let's take what time is it? 9:37. Let's say 9:50. 9:50. We'll come back. Take a break.
Roger.
Share. Clean this up, clear all drawings. So just to give you a heads up, guys. Look at going in my door.
Yeah. It's a little noisy.
I got a question out there. I don't want you guys to get tricked by it. Always losing this pen. I just go ahead and state it out here. Well, everything's going to be green this time. On that breaker handle, and you've got the green indication and the red indication. Sorry, they're both green. All right, so on the handle right there, I'll read you the question. When the breaker handle flag is green and you have a green light in the breaker is, and I want best answer here. Now listen to this. Closed, working, open, a non-visual open. When the breaker handle flag is green and you have a green light, what does that mean? Let's start with that. Is the breaker open or closed?
I mean, it's open.
It is open. Okay. So we can disregard the first two, closed, going, and working. Now I'm down to the last two, open or a non-visual open.
Non-visual open.
Non-visual open. Okay. You cannot see inside the mechanism of the breaker. Remember how those contacts went together? That's all hidden inside a tank. We can't see that.
Got it.
Got it. Okay, that's a non-visual open. That's why I put in the question, best answer. So make sure that doesn't trick you.
I thought the color was your visual.
Nope, it's not a visual. When I say visual open, I'll give you the definition here, is air between contact points. There you go.
Gotcha.
I have to see air in between the two.
Okay.
Open, the open bus side disconnects and line side disconnects. When those open, I can see air in between.
Got it.
Okay, good deal.
All right.
I got a question about the quiz.
Sure.
How many questions are on it this time?
Stand by. Get my mouse back to the process right here. I'm pretty sure there's 25. There are 25.
Yeah.
Okay, thank you.
Now, when the breaker handle flag is red and you have a red light, the breaker is closed, true or false?
I mean,
Red.
is closed.
There you go. Good deal. Okay.
Mhm.
I'm checking these as I go to make sure we got everything covered.
Okay.
All right. All right, make sure this doesn't trick you up either. To operate, and this is fill in the blank, to operate the breaker locally, I'm not saying open or close, I'm saying operate, anything inside of it, I must have the breaker local remote handle in what? Local or remote?
Local.
Local, okay. All right, don't let that trick you. I can open the breaker without that, but I'm asking operate, not open. Okay, let's see, make sure. All right, let's redefine, make sure we got this right here. We spoke yesterday of a breaker operation. What's included in a breaker operation?
In a breaker operation, what's it? You have.
So we have a trip open, right?
Mm-hmm.
And then what else does a breaker do? It can trip
Closes.
and it can close. That is one operation. Both steps. not just the trip, not just the close. A trip open is exactly what it means, a trip open. A close is exactly what it means, it's a close. Both of those equate to one operation.
Okay.
Understood?
Roger.
Roger. So your boss man or the dispatcher calls you and says, Scott, we just had an operation on breaker B out of Singleton Ridge. What did the breaker do?
It tripped and closed.
It tripped open and then it reclosed. Okay. All right. My question would be, is it closed and holding? He's going to say yes. Is it in timed operation? Yes or no, whatever that answer may be. But operation to me and in the world equates to one trip open and a close. That's one operation. Okay. All right, let's go. Mouse. Just make sure I got all things touched base with you guys. Might have a couple of things more. That's got that one. All right, you guys do know what a fault is. A fault, that question is going to be a written answer. All right, you know what overload is. All right. Here's the question, and it's got 1, 2, 3, 4, 5, 6 possibilities here as an answer. What does the breaker do when I have a hotline work permit, HLWP? First, nothing. It acts as normal. 2, it operates. Now, by definition, what's an operation? We just talked about it.
Well, you said what again?
Trips open once and closes it. One
Trips
operation.
and closes. All right. Remember, I'm asking, what does a breaker do when I have a hotline work permit? It operates. Trip close. No, I'm not going to use that one. All right. It closes after detecting the fault. Nope, I don't want closes. I want a hotline work permit. It opens and locks out. It opens and does not reclose. It disables all the relays in the breaker.
That's the one.
You got two kind of sketchy answers right there. But I have not said that it's done one. So let's go by, let's talk this out and just kind of get rid of the bad ones. Nothing. Does the breaker do nothing and act as it normally does when I have a hotline work permit? No. Does it operate? Heck no. We hope not. Does it close after? Well, we don't want it to close, period. Closes after detected fault? No. Okay. Does it disable all the relays in the breaker? Well, we don't want to disable all of them. We want A, B, C, and G to make the breaker open. Okay. All right. Does it lock out the breaker? Have I ever said that?
No.
No, and it does not lock out the breaker. Does it open and not reclose?
You can do that.
Yes. Okay. It opens and does not reclose. I don't need to take the breaker to lock out. What takes the breaker to lock out? As explained yesterday, an I and what? It took an I, by the way I explained it yesterday, and 2 T's to take the breaker to lock out. Right? I don't want the breaker to go through the I, T, and T. I want it to go to I open immediately. So it's I, instantaneous, and does not reclose, not locked out. Okay. Questions there, concerns? All right. Let's get rid of that one. Rob, are you looking at questions too?
Yes, I am.
All right, Let's see how well they do with this.
Okay.
When is a hotline work permit required? When do I need to get one?
Before you can start with it.
Whenever
I
you're
don't-
working with Energize.
Do what, say it again?
I'll throw out the
Whenever you-
choices. Go ahead.
Oh, I was just concerned whenever you work with Energized.
Secondary or primary?
All right, man. Probably both.
Mhm.
Okay, secondary is not required. Hotline work permits, in fact, there is no real way. If you have a secondary fault, the breaker won't even recognize that. Is so low intensity and the voltage is so low, it just won't recognize it. You might blow a fuse, but you're not going to be able to operate the breaker. Let me give you your choices here. When is a hotline work permit required? While connecting a secondary service, while closing a switch with an extension stick, when working on or near overhead primary, when sagging a feeder neutral. Which one fits the
The
best?
third one.
The third one, when working on or near overhead primary. Okay, good one. All right. Let's see. Define a breaker lockout.
Isn't that where it basically locks itself out and it doesn't come back into operation?
Okay. Answers: a lock on the door of the breaker. Wow. Breaker is currently operating. Breaker is open due to a hotline work permit. The breaker has completed all operations and needs human intervention.
A.
Say it again.
A.
A
Yes, sir.
lock to the
So
door.
A,
of
a lock
breaker?
is on the door of the breaker.
That's what you do when you lock something out. You put a lock on it, right?
No, I'm talking breaker lockout.
Breaker lockout.
Breaker
Oh.
lockout.
Repeat the question.
All right, sure. Breaker lockout is a lock on the door of the breaker. Next, breaker is currently operating. Next, breaker is open due to a hotline work permit. Last, breaker has completed all operations and needs human intervention.
Okay.
The last one.
The last one, okay, we discussed it
Yeah.
yesterday. Once I have completed my I operation, my T operation, and my T operation, the breaker will go into condition lock out. Okay, this is not lockout tag out. This is what the reclosing relay is doing. It will go into lock out. When I say human intervention, it might be human intervention via SCADA or on site, but some kind of repair
I'm gonna come on.
or
What?
patrol needs to be done before that breaker can be closed again. Okay. Glad we went over these.
Yeah.
All right. As soon as you are hired, you can close a breaker if needed. True or false?
False.
False, yeah. Okay, there's only one thing that you have the capability to do as a brand new employee, and that is get a hotline work permit. All right, you can get a hotline work permit. Some companies will allow you to, if it's an emergency, say you're driving down the boulevard and you see a wire on the ground, you can call the dispatcher up and say, I need you to open this breaker up. You can get it open. That's for safety features. You cannot reclose. All right, you cannot ask for a close. You can also get a hotline work permit. We'll talk about the procedures for that in just a moment. So, the next question, you can get a hotline work permit as soon as you start employment, true or false?
True.
True, yeah, I just said that. Okay. Now, let's talk about hotline work permits as far as you as a brand new person are concerned. Change my format to black. Let's clear this here, clear all my drawings. All right. So how do you think the process goes to get a hotline work permit? What do I need to do?
Call your dispatch.
Call dispatch, excellent.
Okay.
Call dispatch. Now, he's gonna need to know where you're at, right? Or where you're working at, correct?
Yes, sir.
All right. There's a
Can you give
couple,
me-
there's a couple different ways. The work request, WR, has the breaker information on it. Okay, so it's going to be on paper for you. If you don't have the work request with you, just give a poll number. All right, if you're working on a poll number, they'll look up the breaker for you and they'll get you a hotline work permit. All right, once you have made that communication, guys, here's what's very important. You *** are responsible for that hotline work permit. So do you think you need to maintain communications or have a radio nearby?
Absolutely.
Absolutely. You have to have that radio nearby at all times. Okay. Be able to make contact communication with your dispatchers. So that answers that question. Right. My dang mouse. When I have a hotline work permit, what kind of operation occurs? Now I'm asking for the operation type. Is it an I instantaneous open? Is it an I instantaneous close? Is it a T timed open? Is it a T time closed? Is it a T tonsillectomy?
What was the question again? I heard the
When I have a hotline work permit, what type of operation occurs? An I, instantaneous open. An I, instantaneous close. Is it a T timed open? Is it a T timed close? Is it a tonsillectomy?
instantaneous open.
Instantaneous open, okay?
Sure.
It's really not a full operation because I have the relay, reclosing relay turned off. I only get half of one. Instantaneous open. That's what we want to happen.
Okay.
Okay. When calling the dispatchers for a hotline work permit, what can I use for circuit identification? Answers: my CDL, my GPS location, my college H number, or the poll number.
Poll number.
Excellent, excellent. Okay. On the breaker panel, how can I tell if there is a hotline work permit on the circuit? Oh, okay. So let's go back to the panel. I won't draw all the relays in. Obviously, it's got something to do with the reclosing relay, right? What relay was over here with the handle on it that turned orange? Anybody remember?
Yeah, it was the reclose relay had the orange.
Okay. The reclosing relay just looks like a normal relay. I'll show you some pictures here in just a moment.
Sure.
But right beside it, I had an orange flag came up when I turned the handle. That was called the tagging relay.
Oh, okay, the tagging relay.
Tagging relay, right. Now, if it's orange, there's a hotline work permit. If there's black, if it's not turned on, okay, the breaker's an automatic. It's just doing its thing. So the question reads, on the breaker panel, how can I tell if there's a hotline work permit on the circuit? There will be a window with HLWP on it. There will be a handle for reclosing relay off with a red flag. The breaker light will be white. The local remote handle will be in local. There will be handle for the reclosing tagging relay that is orange.
I'll be tagging relay, which is orange.
Tagging relay is orange. Just follow the colors.
Yep.
Yeah.
Okay, we need to fix that answer, Professor V.
Yeah.
Okay. All right. And mousy. Where are you? Okay, so let me go through all of them here, make sure we cover all our bases. Substation for distribution, transmission, breaker opens, how many relays, visually breakers identified by. You do that one? Push, okay, that's cool. Yeah, who determines the amount of T's and I's? Breakers are typically, which relay opens, the reclose relay only, when the breaker handle flag is green, red, fill in the blank, line fault, we know that. Just so we can review on this, I asked you the other question, define a line fault, okay? What is breaker overload? Now I defined it to one piece of equipment, but you could have overload situations in conductors, transformers, fuses, a lot of stuff. What is breaker overload?
When there's an overload of power,
No. I want you to be more specific. Power is voltage in amps.
so say like the A, B, and C, it's where one of them has an overload of power, so it gets put off on the other one.
You need to get off the power thing. Okay. And I want you guys to start taking, when you see the terminology, it's just like ACI. When we talked about the ACI the other day, automatic circuit interrupter, I asked, what does it do? And you guys flip some words around. Automatically interrupt circuits. Perfect. That's exactly what it does. Voltage regulator, flip those two words, regulates voltage. What is overload? Load refers to what?
Refers to resistance in the circuit.
No.
How many amps is that?
Amps, there we go. Amps and current. Load is amps and current. That's what that refers to. Now, overload.
Say,
What is breaker overload?
pulling too many amps or pushing
Yeah.
out too many amps?
No, whatever the piece of equipment is, conductor, transformer, fuse, you've gone over the limits of amps load on that piece. So if I said yesterday, if I've got a 20 amp fuse, let's go ahead and do a little math here. It will go to 150%. So it will do 30 amps for a short period of time. Well, what's wrong if it does 40? Is that overload?
Yeah.
Yeah, I've gone over. There's no fault, guys. There's no short circuits. There's no wires on the ground. There's nothing happened there. But I've gone over the over the load limits of that piece of equipment. Now I'll ask this question again. What is breaker overload?
Over the limits of amps load on that piece of equipment.
There you go. Exactly. I've gone over the limits, the capabilities of the breaker in load. I'm in breaker overload. You're thinking too hard on this. We went through a breaker yesterday. I think Lenny pointed it out. I zoomed in on it. The breaker was capable of doing 1,200 amps per phase. So that's 3,600 amps total. What's wrong with the breaker when it's doing 3,900 amps? It's in what? Breaker overload. Okay.
Question, right? Because I hear the term overcurrent on
Same thing.
circuit.
Same thing.
Same thing?
Same thing.
I mean, why do they have two different, I mean, there's two different technical terms. Can't they, I mean, like what distinguishes one from the other, you know?
Okay, so let's talk about load. We talked about this a long time ago.
Yes, sir.
Let me before we get into that, make sure I get everything. Breaker, do what I have. Breaker lock, as soon as you hire, close breaker. Yeah, we've got them all. Robbie, remind me on what question was that?
25.
25?
Yeah, with the,
Change that to red to orange?
yeah.
Okay, gotcha. All right, so let me clear this off real quick, and it might take a little time, and we did discuss this before, but I'll discuss it again. All right, so I'll just put a breaker here. And for purposes of just keeping some even numbers, I'm going to put 3,000 amps. That's what the breaker is fully capable of, 1,000 amps per phase. And we'll go out here, we'll put an open point, let's go on. Tap lines, fuses, transformers, all this kind of stuff, right? The breaker is open. Is there load on this circuit? Can y'all hear me?
If the breaker's open, there is no load.
Anybody else?
Yeah, there is load.
Yeah, there's tons of load out there. It's not energized, but there's a lot of load out there. Okay, it's not energized yet.
So, okay. So my understanding of load, and if I'm wrong, you know, please correct me. It unless there is something, unless there's something in the circuit to absorb that current.
Now you're talking current, not load.
Okay. All right. So those, what do those lines represent again?
Tap lines, fuses, all kinds of stuff down the street.
Oh yeah, that's load. That's definitely load. Yes, yes.
Okay, with the breaker open.
With the break, it's still load. Yeah.
That's right. That's still an existing load.
Yes, sir.
Okay. Now, if there is existing on my circuit 3,500 amps of load, you know, it can consume that much. Is my breaker an overload even when it's open?
Yes.
Yep.
Not really.
Sure is.
Oh, you said 3,500. Oh, yes, it's an over.
Yeah, it's still in breaker overload. Is current flowing?
Mm-hmm.
No, my breaker's open.
Yeah, no, current is not flowing. No.
My breaker's open. So that's breaker overload. Okay. Once I close the breaker, is this load still here? Closed now.
Once it's closed,
Right.
yeah, it's going to trip.
From what? Overcurrent or overload?
Overload.
Okay, actually both.
Well, I mean, because the overload is going to cause an overcurrent.
There you go. That's why I just said about 5 minutes ago, they're the same.
Yeah.
With a closed breaker.
Enclosed breaker, yeah, that, okay, got it.
Okay. Yeah, you guys keep in your minds now, and this is going to come on into your careers. When you guys are opening and closing fuses on transformers or tap lines, be prepared for load. Okay. It might not be energized yet. And a good dispatcher will tell you, especially when you're operating feeder switches, Scott, you're going to be picking up a lot of load. Was the load energized? Not yet. I haven't closed the switch yet. Okay. That's a good thing to remember. Load exists whether it's energized or not.
The way, I don't know, the way I mean, yeah, I mean, that's good. The way I was understanding it was like the load is basically resistance in the circuit, you know?
No, load is current.
All right, all right, hear my thought process out, all right? Because we can go back to Ohm's law on this, right? All right, so a certain object, device has a certain amount of resistance, correct? And then the voltage being provided, let's say, is 120, right? Based on the resistance that that device has, right? And based on the voltage that is going to be given, it's going to require a certain amount of current.
Correct.
So but the source is providing a certain amount of, can only provide a certain, right? So if you put too many devices on that circuit with that over exceeds, right, the resistance that's gonna exceed the amount of current that the source is providing, then in turn is gonna cause, yes, the overcurrent. But what I'm understanding of the load, that the load is the resistance, it's the load in the circuit, the amount of work that needs to be provided in the circuit. That's the way I understand it. If I'm wrong in,
Okay. So
that
there is obviously, all right, so I'm gonna clear the screen up. I can see kind of where you're heading. I just want to make sure you get your, as far as your terminology, you know what you're talking about when you're
sure, and I could maybe I could draw it out better than I can explain it too.
Okay, so I got my breaker.
Okay.
We don't need to put values to it. Let's say the circuit is 5 miles long. Is there resistance in this 5 miles?
Yes.
Okay, how much load is flowing?
How much load is?
How much load is attached to it?
No, it's a bad. I can't.
Zero. I didn't attach anything to it. So how much current is flowing?
Oh, you talking about the wind current or something, or
Wind current? What?
I mean, how can I relate this?
Amps.
Okay.
5 miles of line, nothing's attached to it. All right. So how much load is on it?
You want to call it?
It's very simple right here. The answer is right here on your screen.
Are you saying 5 miles is the load?
What's in front of load?
Zero. Okay.
Okay. So how much current is flowing through the circuit?
Zero.
Okay. Well, that just defeats your definition.
No, I can explain it. I mean, I can draw it down. You want? I can write it down. All right. You mind if I share a screen?
Go ahead.
All right.
May I share mine? All right. So hold on one second. What time is it? Yeah, we got a little time. Serge is here.
Hey, sir.
Let me unshare mine. Stand by.
Roger.
I can get my mouse over there. No, I got 5 screens I'm working on over here. I'm lost.
I'm gonna come back with the Ethernet cable. I think it's the cable that's.
Okay.
But you're good to go.
Okay, go ahead.
I'm gonna come back.
Hold on, let me open up,
Right on.
all right. Let me draw a circuit, okay? Where's the, okay, draw, okay. So here's a power source, right? Call it whatever you want, you know.
So you're talking a generator now?
A generator or a transformer, whatever. There's a power source.
No, a transformer is not a power source.
Okay.
A transformer transforms voltages, it doesn't create them.
All right, I'm just gonna draw numbers. All right, so there's 120 volts given to a house, and I'm gonna work with lower numbers, all right? And you have 10 amps.
Okay, so you have load and you have
Right?
current, okay?
In a circuit, and then this is my line circuit. In the circuit, you have a okay. So in the circuit here, I'm gonna draw a parallel. I'm sorry. Just little circles are loads, right?
What is that you just drew in?
They're loads. Could be that could represent a receptacle, that could represent a light, a TV is a load. They're loads.
Okay, so your top wire is energized, your bottom wire is neutral.
Yes. Yes, sir.
Okay. Okay.
All right. So hold on, let me draw another one. Let me draw another load. Let's see, I'm gonna say, all right, so the voltage given is 120 volts, right?
Okay.
Divided by, let's say this requires 5 amps. I mean, it gives off 5 resistance, right?
What gives off 5 resistance?
5 ohms, 5 ohms, 5 ohms.
What gives off 5 ohms?
That first load I'm drawing right here. Okay, you see it?
It just
What's your
gives
question?
it off.
No, it gives. It's
Raise
not
it
that
out like a sprinkler. What are you talking about?
No, it doesn't give it off as it has a resistance. It's not that
Okay.
it has a resistance of 5 of hold on,
Gotcha.
excuse me. Hold on. Wait. Bear with me just 120. All right, hold on, let me erase this. All right. Where's my drawing? Where's my all right. How do I get back to my pencil on this?
Hovered over the screen that you. I don't know what you're using.
I guess I was using
You're using an eraser. If you
the
can go
whiteboard.
over, if you got like a menu.
Oh, here it is. The drawing. Yes, sir. I got it. Thank you. So let's say this has 24 ohms, right?
Okay.
Same thing. This one gives. Wait, it's not that it gives. It's 120 volts is being provided. This one has 24 ohms. They all has 24 ohms. All right, let's just put it in some simplistic terms.
Okay.
All right, 120 volts divided by 24. Sorry. 124. Okay, it's 5 amps.
Okay,
All right. So that means every device here is going to need 5 amps.
Good. Yeah.
All right.
yeah,
That means that the total amperage, right? Total amperage, amps in this circuit is going to be 20 amps.
understood.
All right. So that means, okay, another thing, I'm sorry, let's go back. By the way, this, everybody, right? Hold on, wait. This circuit is open.
It's
All right.
open.
It's open because I haven't provided power yet. It's
Got
open.
it. Got it.
I just installed all these devices in this circuit, and
Got
this
it.
is 20 amps. The
Correct.
moment I close this circuit, now overloaded. You understand? Because this whole circuit is required 20 amps, but yet the source is only wherever the power is coming from is only given providing 10 amps. So that goes in overload.
Correct.
So you see how the load relates to the resistance in the circuit and not directly with the amperage, with the current.
But load is measured in what?
But you see what I'm saying right here, correct?
I do. I mean, that's the fundamental properties of electricity.
Yeah.
What do we
So
measure load in?
okay, it's the thing is the resistance that causes the circuit to go in overcurrent, overload.
Understood. But what do we measure the load and current in?
The load and current in well, it's measured. Okay, it's measured in amps.
Thank
All
you.
right, we measure it in amps.
Right. If I raise my voltage, my amperage is going to drop. If I lower my resistance, my voltage is going to, all of those factors are working in there. But what the final outcome is, as far as overload is concerned, first, what trips or closes, what's under, and we're talking about breakers, what's under the bushing of the breaker?
Under the bushing of the breaker.
What do we need to transform before we meter or measure it?
I'm sorry, a current transformer.
Current transformer, which is in amps.
Amps.
It's not a resistance transformer.
No,
It's not a voltage transformer. It's a
it's a current transformer.
current. There you go.
Correct. Correct.
Okay.
All right.
All those variables, you got to remember, all those variables that you have there, voltage, resistance, whatever, they can all change in the world. But the factor that opens and closes a breaker in a substation is amps. The reason why I go into overload is because of amps. Overload. Load exists on the circuit, whether it's closed or open. Amps.
Got it.
Right?
But I guess my question is, overload is not when okay, I hate, I'm probably gonna use some incorrect words over here, okay? I just want to make sure that overload or overcurrent is not when the source current is too high, correct?
It is when the source current is too high.
Yeah, but this is okay. In this case, the example I just provided, the source current was 10 amps.
Right. And your overload is 20.
And my overload is, yes, it's 20. It's 20 amps.
So yeah, you just answered your own question there. It's overloaded.
Okay. So I'm trying to So here's the thing. If a generator is only providing 10 amps,
Mhm.
can a generator provide amps?
Sure,
It can, right?
it's got to. Otherwise, I can't power anything with it.
It's got to, right? But yet the demand is higher than what the generator can put out.
Correct. That's overload.
What happens to the generator?
It trips the
Trip
breaker.
It trips, right?
Right.
All right, so is it so? Okay, I guess you made. I guess we can conclude this with it's a generator that provides the overload, right?
It doesn't provide overload.
It doesn't.
It
Okay,
sees and you're going to the generator. Okay.
yes, sir.
If you took the generator and took the breaker out of it,
Mm-hmm.
you just roast the generator.
Roast the generator.
You got to put a breaker in.
Okay,
Generators have breakers. Right? If the breaker is rated at 10 amps and you're applying 20 amps to it, the breaker's going to open just like it does in a substation. That's overload. Right? Does a breaker have a voltmeter in it?
does a breaker have a voltmeter?
Yep.
Might. I don't know. It
No.
might be.
No,
It might
no,
be triggered
no,
by
no,
a meter.
No. Don't go there. Don't go there.
Oh no,
Does
there's
the breaker
so many-
measure voltage?
That's not its purpose. No,
Does a breaker measure resistance?
no.
Does a breaker measure amperage?
Yes.
Amperage is load.
Okay. Got it. Understood. All right.
Okay. I can see where you're headed with the voltage and the applied resistance and voltage you have in the circuit, but it boils down to breaker operation. At the station, I'm measuring amps. A breaker in my panel, I'm measuring amps. Okay. That is the sum value of what you have added there. But those are the factors that trip it, either by overloading the circuit or a fault on the circuit.
Okay.
Load, current.
Understood. All right.
Okay.
Thank you, sir. Appreciate it.
Okay. You're
Let
welcome.
me
Right.
unshare this.
All right. Any questions on what we reviewed today? Any questions on any circuit of choice? Okay, guys, we'll go ahead and post this up. I'll post the video. Yesterday's video is already up, so you got half of it there. I'll post this video here and let you know as soon as it is up. You've got the quiz today. Have a safe weekend. If you've got any questions, let me know. We'll be here this afternoon. Well, no, we won't be here this afternoon. We will be here till 12.
Mr. Shoemaker, I got a quick question.
What is it, by the way?
What